Now I present the PPILOW results related to my first presentation and the presentation of Professor Castellini all together. As already presented by Professor, we have performed two different experimentations. One, a preliminary study where we test a lot of genotypes to choose 4 best genotypes to test in the outdoor system with different enrichment, okay? Here I reported the different genotypes that we tested, the Ranger Classic, Rowan Ranger, Gold, Red Jay, Neck and Neck, Loman Dual, Meat-oriented, and 2 Italian crossbreed, Robusta Maculata. The native chicken breed is male line crossed with the female line of Sassou, okay? And the professor showed you the results about the foraging behavior of this animal, and we choose to analyze in the different enrichment the Red Jay, Neck and Neck, like good genotypes in terms of performance, but with lower or medium foraging behavior. A dual purpose Loman Dual like a dual purpose, and a crossbreed like a good compromise between foraging behavior and product quality. And we test these 4 genotypes in the outdoor system with 2 different enrichment. We have done 2 different cycles. The first one when we compare the presence of sorghum like crop and the control the outdoor system without pasture, and the second one where we had not an enrichment for the weather problem in this season, and so we have to choose to test to compare the presence of pasture and the absence of pasture. The aim of the task 6.1 of PPILOW project is to build a provisional index to understand the genotypes adapted to the outdoor system. To analyze, to respond to this goal, we have analyzed 206 variables and considered the difficulty in the number of variables here are reported. In order to simplify the results reading, we have chosen to use a principal component approach, which means that we have classified all these variables in 7 principal components based on the different characteristics explained by these variables. And we built the PC1 for the behavior. Here are included the traits analyzed, the weight traits, the physical chemical traits, meat oxidative status, meat fatty acid profile, in vivo oxidative status and fatty acid profile all together, and blood traits. And inside each PC principal component, we choose the variables, the criteria with the higher weight, which means that we have running, for example, with the higher weight in positive sense, and scratch with the higher weight in negative sense. In the weight traits, we have the carcass weight and the breast score. Breast score refers to the feather condition, okay, analysis. The drip loss of drumstick, the red color of breast, the lipid of drumstick, the total lipid, the carbonyls, which is the protein oxidative status, a marker of protein oxidative status of breast. Here we have the polyunsaturated fatty acid, the total polyunsaturated fatty acid of breast, the arachidonic acid of drumstick, polyunsaturated fatty acid of blood, lipid oxidation of blood, malondialdehyde test, the erythrocyte of blood percentage, and the ratio of heterophil lymphocyte percentage. We use just an an objective approach, okay? The PCA gives us the weight of these parameters. To evaluate if really the weight explain really the variances between these parameters, we analyzed a statistical test of variance, and we found that the explanation is here reported. Running explain 21% of variables. We can consider a good marker, a good variables to discriminate the different group analyzed, followed by polyunsaturated fatty acid of breast, 14%, carbonyls of breast, 11%, the ratio heterophilic lymphocyte, 10%, carcass weight, 8%, and so on until little variation. Which means that this is a good variable to see that if there is difference between genotype analyzed, between enrichment analyzed, or is not good because it not explain the variance between the different effect analyzed. Here we calculate the index. Is very dangerous. I go away, but if you want, we can talk about this. And we produce a final index, this one, okay? We can consider the adaptability index for the different genotype, crossbreed, Lohmann dual, neck and neck RJ, in presence of enrichment, pasture, and not enrichment, pasture, not pasture, okay? To simplify. And we analyze the results. By the results, we found that about the genotypes, we have a good, an higher adaptability index for red J, similar to Lohmann dual, followed by neck and neck, and the crossbreed the worst one. For the enrichment, we don't find any difference. We have a lot of variability. So, we thinking about the application of this index in on farm or in commercial viewpoint, and we thought that maybe also if we don't have 206 variables, but we have seven principal components in positive and negative sense, which means 14 criteria to analyze. We think that maybe it's hard to analyze 14 criteria in on-farm trial, and we try to reduce this criteria with an objective approach. We take in consideration just variables with higher variance explanation. For this example, we choose to excluded value less than 7%, and in this way we can explain 71% of variance in our system. And here you can find the variables included in the index, in this new step index, okay, in the second step. You can find that we have different results. We have that the higher adaptability in RJ, like the first one where I included all the variables, followed by neck and neck, Lohmann dual crossbreed is maintained lower. The enrichment not change. So we can introduce other variables, okay? We try to introduce other variables to try to arrive to the first hour hypothesis. Yeah. And we exclude the value less than 5%, and we obtain a variance on 83%. We try also 2%, and after we include all variables, obviously. And we have this trend. We have just 70% as already shown, and 5% we had the same of 70%, 2% is the same. So what it means all this tentative to obtain the same variance? Means that the genotype affects strongly the adaptability of rearing system. The enrichment not so not so higher, is not explain the effect, okay? The choice of the criteria of the variables, to include in the index is very important. More criteria, more variables produce a more robust index, obviously. but it's normally it is necessary to reduce the number of variables for the large scale or on-farm application. How we can refine this index? Mainly to include more genotypes in this test, to include more variables, also to share the data with the other PPILOW partner, for example. In this way, we can also to increase the weight of different criteria chosen, and then to obtain a more objective index to apply in on-farm. Thank you very much. Here is reported also the team.
Thanks for the presentation. Maybe a technical question regarding the PCA and how we calculated the index. Am I right in understanding that the index is a sum of the different loadings? Because I was wondering, could that not mask some differences that, for instance, with some specific variables, those would kind of increase, others would decrease, and for another string, that would be reversed from that, so you could potentially get a significant difference, but which is kind of masked by the fact that you're summing and lumping all of these loadings.
Yeah, it is possible. It is possible, yes. In our approach, we try firstly to use an objective way to include all variables in one PCA and show how these variables groups, but it's not possible, not. So we have tried to drive and has the variables to include, for example, based on the matrix, meat variables, blood variables, behavior variables in vivo, and so on, and we obtain this type of classification. Okay, but the really in the PCA use is that more data you have, more specific, and the weight is strong. Okay, to obtain. For this reason, I think that the data that we obtain by these two trials is not sufficient to discriminate the different criteria to use. It is a good approach, but it's better to implement with our other data, yeah, to have more robust results in the index. Yes, thank you.
Thank you, Simona. I think that your trials are a big opportunity to maybe develop a prediction model or equations to estimate the final weight of different strings. I don't know.
Yeah, normally, as you say, you can see the final weight, for example, the live weight is not reach a good weight to include in the PC2, but the carcass weights, yes. This means that maybe in this case with these variables the live weight is not sufficient to discriminate, to identify the adaptability of the animal, like the daily weight gain, for example. All these variables are included inside this one, but also I not say this. I excluded all variables in the PCA that produce a weight less than 0.3 because it's very low, okay? And these variables are included, but it's not presented here because it's very low. I not considered that, okay?
I mean, maybe we can use these indicators, all these variables, to predict and estimate the final weight, which is
this variable, the final weight.
Yeah.
Yes, it's possible.
It's
possible to inverse. So yeah, it's possible, but now we are not interested in estimating the final weight because we have the final weight.
Yeah.
But generally speaking, yes, you can rebuild the live weight.
It will help in the decision making of choosing the strain. I mean, well.
Yeah, the problem is that our aim is not to classify the genotypes adapted to the author based on the live weight. We don't. Okay, it's better to take in consideration all variables with the after we talking about this, about with the use of a multi-criteria approach to not fix to the daily weight gain or live weight to classify a genotype, because this is the approach that we have now. This is the approach, but it's not good, because in this way we can have some problem, like for example the use of fast growing, which fed less in extensive system, that is not good. Okay, we have to consider other variables.
Thank you.
Thank you too.